Welcome back to another CADCAM tutorial. This is a Siemens NX 3D modeling exercise, and you are going to model this part. So guys, this is a drawing for the part, a section BB through this view, a section AA as well, and then this is the front view and this is the top view. All dimensions are in millimeters. All unspecified fillets have a radius of 5. So these edges have a radius of 5 for the fillets, and the thread on this shaft has a size of 46 by 5 millimeters. So this is very simple, but it looks complicated when you look at it. Just make sure you watch the video to the end so you know how to model this pipe. And please like the video, subscribe, and turn on post notification so you do not miss any Siemens NX 3D exercise. And also share the video to your friends so they can also watch it. And let me know in the comments if you have any problems, and I'll be glad to help. We can now start. We start in the Siemens NX 3D modeling workspace. The first thing we are going to do is to add this first feature, the oval feature and the circular shaft that runs through it. Since they are circular features, we are going to use the revolve command. So under the extrude, we have the revolve command here. You have to sketch the section. So come here, and then we sketch on the YZ plane, which is the right plane. So we are going to sketch half of the profile and then revolve around the horizontal axis. So we start with an arc by 3 points. The first point here, second point here, and the third point here. Then with the profile tool, we close out the shape of the shaft. When you zoom in, you can see that this point and this point, they are not coincident. So click on the 2 points, coincident. Now we have to add some constraints. So we make sure that the center point of the horizontal line lies on the origin. The radius of the arc is 65. So click on the center point and the origin, coincident. Radius of the arc 65. Looking at the top view, you can see the diameter of the shaft is 46. Same for this shaft as well. So just click on this line and this line. Make collinear, as well as you make them equal. Now the full length is 225, and the length from this end point of the arc to this line here is 65. And the diameter of this shaft here is 46. Since we sketched half, so 46 divided by 2, that will be 23 millimeters. Sketch is fully constrained. Finished sketch. And then the axis of revolution, click on this horizontal line. Okay. Next, we add this shaft. Has a diameter of 56 millimeters, as a length of 120 millimeters from this origin or this sketch plane. So we use the extrude feature, sketch section. We select the XY plane. Okay. So a circle of diameter 56 millimeters and a distance of 120 from the middle of the feature. Set the boolean to unite to join with this feature here. Okay. Next, we add this feature coming out here also. We're going to create the sketch on the front plane. So again, extrude, sketch section on this front plane. Okay. So the circle has a diameter of 40 millimeters at a distance of 55 from the front plane. Now the distance from the center point of the circle to this point here, which is the midpoint, is 72, and the circle is in the middle of the part. So we make sure that this center and this center vertical alignment, and the distance between them is 72. Sketch is fully constrained, finish, and the extrusion distance is 55 millimeters. Set the boolean to unite again, apply. Then there is another material coming out here. We're going to create a sketch on the right plane. So again, extrude sketch section, and then select the YZ plane, which is the right plane. The circle has a diameter of 30. Make sure the circle is in the middle of the shaft. So click on the center point of the circle and the origin here, horizontal alignment. And the distance between the two centers should be 74 millimeters. Now sketch is fully constrained, finish. And you're going to extrude by a distance of 65, looking at this section view. Okay. We have another feature here, which is also a cylinder. So we are going to create the sketch on the top plane, and then we extrude via the symmetric method. We extrude sketch section. The top plane is already selected. Okay. So a circle which has a diameter of 40 millimeters, and the center point should be here. The distance between these two centers is 74, and this will be 65, so maintain it. Sketch is fully constrained, finish. Now the length of the cylinder is 60 millimeters, so a symmetric value and half of 60, that will be 30 millimeters. Boolean unite, okay. Now we are done with adding the shafts. We now add the flanges to all the shafts. So again, extrude sketch section on this face, okay. Now this flange, as we can see, has a diameter of 60 millimeters and a depth of 20 millimeters. So a circle of diameter 60, finish, reverse the direction, and a depth of 20 millimeters. Boolean unite, apply. Then another flange here has a diameter of 52 millimeters and a depth of 16. So again, sketch section with the extrude feature on this face, okay. So a circle of diameter 52 and a depth of 16. Reverse the direction, Boolean unite, apply. There is another shaft here, has a diameter of 92 and a depth of 10. So again, extrude sketch section, rotate the sketch, click on this face, okay. A circle of diameter 92 and the depth of the flange is 10 millimeters. So reverse the direction, okay. Now you're done with adding material. Next, you're going to remove material. First off, we remove this overall feature here. The same way we did the revolve, this time you're going to revolve and remove material. So again, come to the revolve sketch section on the right plane. So again, we need an arc from this point to this point. Then we need a shaft that runs through. Place the center point of this horizontal line on the origin. And then the radius of the arc is 62. Diameter of the hole is 30. So this length will be half of the 30, which will be 15 millimeters. Make sure this line and this line, again, collinear, and they are equal as well. And we align this point in the center here. So click on the center and this point, vertical alignment. And this distance, as we saw here, was 65 millimeters. Now sketch is fully constrained, so finish. And then this time, the axis, click on this horizontal axis, specify points. We are going to use the origin. So come to this point dialog. The X reference 0, Y reference 0, and the Z reference also 0. Okay. So it will automatically select the origin. The Boolean this time subtract. Okay. Then we add the thread of size 46 by 5 millimeters. So locate the thread feature, detail thread, and click on the shaft. The major diameter 46, which is here. Minor diameter, let's go with 42, and the pitch is 5. Now the length of the thread is 30 millimeters. Come to select start and click on this face. Reverse for the thread to go inside. Next, we add a counterbore hole here. So with the hole feature, a form of counterbore diameter 46, counterbore depth 5, and the hole diameter 40. The depth limit until next. Come to sketch section on this face. Okay. Now with the sketch point tool, place the center of the hole in the center of this shaft. Finish. This is okay, so apply. Now we need a hole here also. So again, sketch section on this face. Okay. Then with the sketch point tool, the center of the hole should be here. The diameter of the hole is 30 millimeters. So a simple hole of diameter 30. The depth limit until next. Apply. Next up, we have another hole here of diameter 24. So again, sketch section on this face. Okay. So a hole of diameter 24 with the center here. Apply. Next, we have these holes here on this flange. They have diameters of 12 and the depth is 10. But since the depth of the flange is 10 itself, so the depth will be until next. Now, sketch section. Click on this face of the flange. You can see the centers of the holes are located on a circle of diameter 70. So we draw a circle of diameter 70 millimeters. We convert the circle to a reference circle. And then the two centers here are inclined at an angle of 90 degrees. So we need a line from the origin to this circle. Again, a line from here to this circle. So the angle of inclination between them is 90 degrees. Then we make them symmetric about the x-axis. So just make symmetric. Primary object, this line. Secondary object, this line. The center line should be the x-axis. Again, convert the two lines to reference lines. And then with the sketch point tool, we place the centers here on the intersection between the inclined line and the circle, and the second one here. Then you're going to mirror onto the other side. So with the mirror curve, click on this point and this point. Center line is the y-axis. Okay, so finish. Okay. Now we can see there is another hole here of diameter 20 millimeters. So this time we use the extrude feature, sketch section. We're going to sketch on the right plane. Draw a circle of diameter 20 millimeters. Now the distance of the center of the hole to this origin here is 74. And then you make sure the circle is in the middle of the shaft. So we'll click on this origin and the center of the circle, horizontal alignment, finish. Then we make sure that the cut comes to this surface. So set the end limit to until extended and click on this surface. Boolean subtract. Okay. And then the unspecified fillets have a radius of 5. So with the edge blend and the radius of 5, click on the edges where shafts meet. Okay. So when you have a section view, okay, so get inside a bit, and this is what we have. Okay. Very similar to this section view. And with the true shading, change the appearance to a glossy plastic wash. And yeah, that's how to model this pipe using Siemens NX. So thanks for watching. That is the end of the exercise. This looks very complex, but make sure you take your time and go through and you know how to model this pipe. I'll see you in the next tutorial. Safe.